Hello everyone, I am back with LeetCode daily questions. Sorry for the long time of period where I could not upload the videos because I was at my office doing work from office only. So yeah, let's start today. So we have today 1637 LeetCode wildest vertical area between 2 points containing no points. Okay, language is little bit far from English grammar. Yeah, given n points on a 2D plane where points I, x, I, y, return the wildest vertical area between 2 points such that no points are inside the area. Okay, a vertical area is an area of fixed width extending infinitely along the y-axis, infinite height. The wildest area is one of the maximum width. Note that points on the edge of vertical area not considered including in the area. Okay, so guys, really I have seen this December we all have encountered easy questions only, and this is the easy question with the face of medium tag, so we will solve it, yeah, in a minute. So basically what's given in the question is we have given some points, let's say 8,7, 9,9, 7,4, 9,7. Like here all these points are marked, right? And now what we want to do is we want to tell the maximum width between any of the 2 points such that none of the point or no points should be there inside the area. For example, let's say we have 8,7 here, and we have 9,9 here, then we have 7,4 here, and we have 9,7, right? Now if you see between these of 2 points there should be no any other point. Let's say if there could be like 8.5, 7, or here it could be 7.5, 8. So it must be between this vertical area, right? So we have to return the area, or you can say the maximum width of that area, where with maximum width such that no points should be there inside, right? And as we know, we could not have a point size, so it's make the easy question also. Why? Because here if you read the question language, it is written what infinite height, infinite height along the y-axis, so there is no meaning of y-axis. You can simply ignore all the y points like 7, 9, 4, 7. The only thing that matters and important for this question is the x-axis points, right? Because why? We want to see the x-axis points which are, and find out the maximum width between 2 points of an x-axis such that no point should be there in between the things. For example, let's say if we have 2 points 3 and 9, we have 2 points on x-axis, that is 3, 9. Now the width between them is 9 minus 3 is 6. Now but the characteristics here, is there any point lies between 3, 9? Yes. Between 3, 9 we have 5, we have 8. So these 2 points are not possible. So in the similar fashion, we have to find those 2 points in which we can find the maximum width also, given that there are no points in between them. So guys, basically what we can do is here, as you can see, the basic approach will also work, the brute force approach, that is we can sort the array, right? If we sort the array on the basis of x-axis, that is 0th element, 0th index, then all the points will be sorted according to the x element, and we will get the array where no 2 points in between them. For example, we can directly get the difference of alternate points and find the maximum of it. For example, if we have this array, right, let's understand with an example. If we have this array, now when we sort it according to the basis of x-axis, then we will get 1, 1, 1, 3, 5, 8, 9, right? Now why we are doing this? Because when we sorted into the basis of x-axis, then we got these points. Now we can simply calculate the difference between of alternate 2 points. For example, index this 1 minus 1, index at 1 minus index at 0, then index at 2 minus index at 1. This will simply give the maximum, the width of 2 points such that no 2 points are lying between them, and then finally we can get the maximum out of this. For example, let's say the basic step will be to sort the array. Now we all know if we sort a 2D array by simply writing sort point sort, we can point sort, and it will, or by default, sort it on the basis of the 0th element, right? And the time complexity of this is, tell me, O of n log n, right? And now simply we will initialize an array that int max width equals to, let's say, 0, because maximum width can be 0, maximum width cannot be negative. So we could also take int minimum, but it would not be a good approach, as maximum width should always be 0, right? For int I equals to 1. Why we are running to I equals to 1? Because we want to get the alternate differences of two alternate elements, and we will start like this. For example, max width equals to max of max width comma points at I minus points at I minus 1. Now what will loop this do? This loop will initialize my maximum width with the maximum difference of alternating points of x-axis, right? So yes, now let's try running this. If I have not make any silly mistake, yes, I have made a silly mistake. That is, this is a 2D array, so I have to do like this: points at I minus 1, then this. Yeah, now it will run fine. Okay, let's say, oh my bad, it is points. Yeah, everyone learns from their mistakes, and this is running good. Yes. So I hope you understood the concept of this question, right? The concept is very easy. You just have to think smart. Here hard work will not applied, right? Here smart work will be applied. Why? Because we have, at first point, we have to ignore the y-axis. Why? Because it's in the question as like we have the areas infinitely along the y-axis, so y-axis doesn't matter for us. What matters for us is width. And how do we calculate the width? By the x-axis points. So we have calculated the width by the differences between alternating x points only after sorting them, so that we have the alternating points in a manner so that there might not be any points in between them. The basic agenda of sorting here is so that we get the alternating x-axis points, so that there is not a single point in between 2 points, right? For example, let's say if this is we can calculate this as non-sorted array, but with the non-sorted array we can get 2 points. For example, 3,9. In 3,9 we don't know how many points are in between them, right? Like 5 is there, 8 is there, but when we sorted the array, we are sure that in alternating points there should not be any scope of a point in between them. That's why this approach is working. And now the time complexity of this, n log n O of n log n, right, plus O of n while we are traversing. So the final time complexity will be O of n log n. Now talking about the space complexity, if you will see, we are sorting the array now, and we are using two things. Like first is sorting the array, and second is initializing this variable to return the answer. Now this we can ignore this variable space complexity. Now if we are sorting the space complexity, it is also something like language dependent. Why? For example, in Java it usually takes log n, right? But in C++ there is a different approach that our by default sorting algorithms through which has the maximum complexity of space complexity of O of log n, right? So thus you can say the space complexity will be O of log n. It's a homework for you also, and homework for me as well, like what all approaches by default that our sort method uses in the C++, right, or any language that you prefer, but the concept will remain same. Sort the array, initialize and maximum width variable with 0, and then traverse through the array from 1th index and find the maximum difference between alternating 2 points of x-axis, and that's all. Our question is done. Thank you for joining in today. I hope you got the concept. Thank you. Bye bye.